Turn to the second page of last night's assignment and look at problem number 1. This should be review. Well, some of these problems should be review of what you did yesterday. So we have 400 to the 3 halves. And we look at the denominator of that exponent, and we see a 2, and we ask, can we break 400 into 2 equal multiplications? So can 400 be split into 2 equal multiplications? 200 would be 2 equal additions. 200 plus 200 is 400. But we're looking for multiplications. 20. So it's 20 times 20. Now to calculate the answer, how many of those 20s do we need? 3 of them. So if I add, or multiply, I guess, another 20 on there, 20 and 20 is 400 times 20 is 8,000. Okay? So number 2 is kind of tricky. Let's just deal with the top. Is there a way to break 1 into 3 equal multiplications? One times 1 times 1. Yeah, we're multiplying, we're not adding. So 1 times 1 times 1. How many of those 1s do I want to keep? 2, and what is 1 times 1? 1. So no matter what the exponent is on a 1, the answer is always 1. So it's going to be 1 over something. Can 1,000 be broken into 3 equal multiplications? And if you don't know, you can always check on your calculator. So let's try 2 to the 3rd. That's too small. 4 to the 3rd. That's way too small. 7 to the 3rd. 9 to the 3rd. I'm getting closer. 10 to the 3rd is 1,000. So it's 10, 10, 10. How many of those do I need to calculate my answer? 2 of them, so the answer is 1 over 100. 1 over 10 times 10. Okay, we're going to skip the next 2 for a second. Look at number 5. In number 5, we're going to treat the top and the bottom separately. So let's consider 81. Can 81 be broken into 4 equal multiplications? Well, let's try it. 2 to the 3rd is 8. Oh, no, 4th, sorry. 2 to the 4th is 16. 3 to the 4th, I found it, 81. So the top is 3 times 3 times 3 times 3. How many of those 3's do I want to keep? 3 of them, and 3 to the 3rd is 27. So my answer is 27 over something. Can 16 be broken down into 4 equal multiplications? Yeah, I already have it, right? Over on my calculator, I have 2 to the 4th is 16. So it's 2 times 2 times 2 times 2. How many am I going to keep? 3. So 2 times 2 times 2 is 8. So 27 over 8 would be my answer. Now before we consider numbers 3 and 4, let's think about this. 36 to the 1/2. What are we trying to do 36 to the 1/2? Are we going to use the top of that fraction or the bottom of that fraction first? Use the bottom. And the bottom says break 36 into 2 equal multiplications. Can 36 be broken into 2 multiplications? 18 would be adding. 18 plus 18 is 36. But we're trying to multiply. 6 times 6. How many of those am I keeping? Just 1. So my answer is 6. Is there another way to turn a 36 into a 6? We could divide it by 6, but we didn't know it was 6 that we were going to use. Let me show you another one. 25 to the 1/2 is 5. 16 to the 1/2 is 4. What do we call this? It has another name, and it looks totally different. Square root. So actually, the square root of 25 is exactly the same thing as 25 to the 1/2. So on your calculator, if you push second square root of 25, you get 5. But if you do 25 raised to the 1/2, then you also get 5. So everybody type in 25 to the 1/2 and raise your hand if you don't get the right answer, because some of you won't, depending on what calculator you have. Did yours work? Did yours work, Emily? Oh, good, good. Okay, so look at this one. 25 to the 1/2, and I get 12.5. Okay, notice how hers looks different from mine. Mine is 25 raised to the 1/2, and hers is 25 raised, and then it's raised to the first, and then divided by 2. So if you have this older software, you need to put parentheses around that. 25 raised, parenthesis 1/2. And I get 5. So you'll always have to do that. Did yours end up working? So if you have a calculator like this, 25 raised to the parenthesis 1/2, parenthesis, enter, is 5. So can I see yours, Dominique? Did you have to do parentheses on yours? So if you have one of these calculators, 25 raised parenthesis 1/2, you have to put those parentheses in or you'll get the wrong answer. Okay. So what's another way to write the third root of 8? Well, if the square root of 25 is 25 to the 1/2, what is the third root going to be? Do you see the relationship? That's because there's a little 2 here that we don't ever write. It's called a square root. So this is a cubed root, which would mean it would be 1/3. Good. So this is 8 to the 1/3. So if I had the fourth root of 81, it would be 81 to the 1/4. Okay? Well, if you look at number 3, we have the third root of 3 to the 12th. Now, there's a really easy way to convert this. It's 3 raised to something over 3. This root becomes the denominator, and the exponent becomes the numerator. 3 to the 12 thirds. So write that down. And the cool thing is, you can do the 3 first or the 12 first. It doesn't matter. So if we look at this problem, can 3 be broken into 3 equal pieces? What would the pieces be? I don't know. What to the third is 3? It's going to be some decimal. So let's not do that first. Let's do 3 to the 12th first. So 3 to the 12th, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Now, how many of those are we going to keep? A third. We're going to keep 1 in 3. So what is a third of 12? So I'm going to keep 4 of these, and that's my answer. 3 to the 4th is 81. So yesterday we always did the bottom number first, but you don't have to. You can do the top number first. It's usually harder to do it that way, but sometimes it's the only way to do it. But you guys are smarter than that. Could I just have done something to this to make the problem easier? What is 12 over 3? 4. So I could have just written 3 to the 4th, and then I would have known that that's 81. Or I could have done 3 raised to the 12th, which is some huge number, and then raise that to the 1/3, and I get 81. Or I could have typed in math, and in math, so math is right here, math 3rd root of 3 to the 12th, and I get 81. So there are a lot of ways to figure this out on a calculator. Okay. So for number 4, can I do a 4th root on my calculator? And let me see your calculator, because yours is going to be different from mine. So if I want to do 4th root, I push 4, math, and number 5 says x root, which allows me to use any number I want. So if I push 5, I have the 4th root of 625 raised to the 3rd, and that's 125. Which we know because 625, the 3 goes on top and the 4 goes on bottom. Can 625 be broken into 4 equal pieces? It can be broken into 5s. 5 times 5 times 5 times 5 is 625. So we take 5, and we need 3 versions of that, is 125. Now on these other calculators, if I push 4 math, and I do x root, notice how mine actually puts the 4 inside that little space, and these older calculators don't. So 4x root, and then we type in 625 raised to the 3rd, and we get 125. And the same should be true of those little calculators. Yeah, 20 bucks to rent one for the whole year. Okay. Pull out your textbooks and look at page number 5. At the top of page number 5, you see a box that helps you know how to convert from radicals to exponents. And you need to be able to do that in order to go on in this chapter. So you see x to the 19 over 20 is exactly the same thing as the 20th root of x to the 19th. So the top number of the fraction becomes the exponent, and the bottom number of the fraction becomes the root. But on the second one, where's the 2? We have the 3 being the exponent, but what happened to the 2? We don't write it, but there is a little 2 in there. We're just too lazy to write it. And then a to the 7/3 is the 3rd root of a to the 7th. So when you finish that worksheet that we're working on, then you also need to do page 5. So when you turn it in, I just want you to write your name, page 5, and there are actually 2 number sets on page 5. You have practice exercise B and practice exercise C. So you're going to do both of those on the same sheet and then turn that in. Number 1, how do we convert 8 to the 4/3? We don't want to know the answer. We just want to convert it into radical form. So I know the 8 goes there. Where do I put the 4 and where do I put the 3? The 4 is an exponent. The 3 is the root. Okay? Look at number 1 on the second set. 11 raised to what power? What's that? Where does the 3 go? It's got to go somewhere. Does it go on the top or the bottom? 3 goes on the bottom. What goes on top? Not a 2. What is the exponent on the 11? There isn't one, so it must be a 1. So it's 11 to the 1/3. Okay? All right, go back to your assignment, the last page. On the last page, the answers are going to be decimals, so you have to use your calculator. So there are 2 ways to do it. I can either type in 87 raised to the 4/3, or I could do math third root, math third root of 87 to the 4th, and I get the same answer. So on that last page, you're just going to use a calculator because the answers are decimals. All right, both of those assignments are due tomorrow. Good luck.